Let's take a look at section 5.4, polynomial equations and models. Let's look at definitions. Polynomial equations are two equations set equal to each other. Standard form has one side equaling 0 and the other side is a simplified polynomial written in descending order. The degree of a polynomial equation is the highest degree of any of the terms in the polynomial equation. The zero product property tells me that if a and b are real numbers or algebraic expressions and a times b equals 0, then a equals 0 or b equals 0. 0 of a function is the value for the independent variable that makes the value of the function equal to 0. And in the typical situation, x is the independent variable, y is the dependent variable. So this is the value, the variable values of x that make the function 0. So when we solve polynomial equations by factoring, if p of x is a simplified polynomial function, if x is a real number such that, or c is a real number such that p of c equals 0, then c is called a 0 or root of the polynomial function. The zeros of a polynomial function are the solutions to the equation p of x equals 0. When solving polynomial equations in standard form, we are actually looking for the zeros of the polynomial function. On the graph of the polynomial function, the zeros of the function are x-intercepts. If x is a 0 of a polynomial function, then x minus c is a binomial factor of the polynomial function. So the process for solving polynomial equations by factoring involves 4 steps. Step 1 is to write the equation in standard form so that one side is 0 and the other side is the simplified polynomial written in descending order. Factor the polynomial completely, set each distinct factor with a variable equal to 0, and solve the resulting equation. Check each solution in the original equation. And the check, unless specified, is actually not required. So you'll be told if the check is required. So let's use this 4-step process to solve x squared plus 7x plus 12 equals 0. Step 1 is to write the equation in standard form. Well, this equation is already in standard form, so I'll just recopy it. X squared plus 7x plus 12 equals 0. It's already in standard form, so there's no work for me to do to get my standard form. Now let's factor it completely. X plus 4 times x plus 3 are the factors of this polynomial. And I set that product equal to 0. Now I take each of these factors and set them to 0. X plus 4 is 0, or x plus 3 is 0. On the left equation, I'm going to subtract 4 from both sides. On the right, I'm going to subtract 3 from both sides. And I find that x is either negative 4 or x is negative 3. Now when I check each solution. So I replace all the x's with negative 4. And I see if the equation is true. So 16 minus 28 plus 12 equals 0. Gives me 0 equals 0, which is true. So that means x equals negative 4 is a solution. Now I replace every x with negative 3. So 9 minus 21 plus 12 needs to equal 0. And I see that that gives me 0 equals 0, which is also true. So my solution set is the set containing these two values. So the set with negative 4 and negative 3. Alright, so let's use the 4-step process to solve 12x cubed minus 8x squared minus 32x equals 0. So our first step is to write that in standard form, which it already is in standard form. So I'll just recopy the equation. My next step is to factor. Well, I noticed that every term contains an x, so my first factoring step should always be to see is there a GCF of every term. And notice the GCF will contain an x. When I look at 12, 8, and 32, I know that 4 divides evenly into each of those numbers. That's the largest number that does so. So I rewrite this as 4x times the trinomial, 3x squared minus 2x minus 8 equals 0. And now I need to factor the 3x squared minus 2x minus 8. So I recopy the 4x and I factor the polynomial into 3x plus 4 times x minus 2. So 4x times 3x plus 4 times x minus 2 equals 0. So in step 3, I set the factors that have the variable in them equal to 0. So 4x equals 0, or three x plus 4 equals 0, or x minus 2 equals 0. And so I solve each of these. The first equation, I need to divide both sides by 4. Second equation, I'll subtract 4 from both sides of the equation. Third equation, I'll add 2 to both sides. So the first equation gives me x equals 0. Second equation, I get 3x equals negative 4, so I'll need to divide both sides by 3 to get x equal negative 4/3. And then the third equation gives me x equal to 2. So let's check those solutions. So 12 times 0 cubed minus 8 times 0 squared minus 32 times 0 is 0. The left side becomes 0. The right side is 0, and this 0 does equal 0, so that's true. Now let's let x equal to negative 4/3. So 12 times the cube of negative 4/3 minus 8 times the square of negative 4/3 minus 32 times negative 4/3 needs to equal 0. So 12 times negative 64 over 27 minus 8 times 16 over 9, and in the third product, negative times negative is positive. 32 times 4 is 128, and that will be over 3. That equals 0. Alright, now one of the things I see is that I can divide 3 into 12 and get 4, 3 into 27 and get 9. And I see that denominator will be 9, the second denominator will be 9. So I want to make this third denominator 9 as well. So I'm going to multiply the top and bottom of the third fraction by 3 so that all denominators are 9. Since I'm going to be adding and subtracting fractions, I need common denominators. Alright, so negative 256 over 9 minus 128 over 9 plus 384 over 9 equals to 0. And obviously, I get negative 384 over 9 plus 384 over 9 equals 0, which gives me 0 equals 0, which is true. So I've got x equals 0 makes the equation true, x equals negative 4/3 makes the equation true, and let's check our final solution, x equal to 2. So 12 times 2 cubed minus 8 times 2 squared minus 32 times 2 needs to equal 0. So 12 times 8 minus 8 times 4 minus 64 equals 0. Twelve times 8 is 96. 8 times 4 is 32. So 96 minus 32 minus 64 needs to be 0. And that gives me 0 on the left, which does equal the 0 on the right. So another true equation results. So all three of my solutions were the actual solutions. Alright, so my solution set is the set containing 0, negative 4/3, and 2. Typically in my math lab, you're going to be asked to write the solution set. Alright, let's look at an application because some real-world situations can be modeled by polynomial equations. To solve these types of applications, we follow the same problem-solving strategy used for linear equations. The first part of the strategy is to read. So an object is thrown upward off the edge of the observation deck of a building. The height of this object, h in feet, t in seconds, after it is thrown is given by the function negative 16t squared plus 72t plus 144. So that equals to h of t is really what the problem is telling us. How long will it take for the object to hit the ground? When the object hits the ground, height is 0. So 0 equals negative 16t squared plus 72t plus 144 is the equation that we'll need to solve to answer this question. So we want to factor our polynomial, and notice that every coefficient is divisible by 8, and I'm going to actually make negative 8 my GCF because it's actually more convenient for the leading term of the polynomial that I'm going to have to factor to be positive. So I'll factor out a negative GCF. So 0 equals negative 8 times 2t squared minus 9t minus 18, and that polynomial factors into 2t plus 3 times t minus 6. So those are my factors. So I take only the factors that involve the variable and set those equal to 0. I do not set negative 8 to 0. That does not involve the variable. So 2t plus 3 equals 0, or t minus 6 equals 0. Now when I go to solve 2t plus 3 equals 0, I get t equals negative 3/2. And I have to actually discard this because this is an application, and t represents time. T needs to either be 0 or positive. So this solution solves the equation but isn't applicable for the problem. But when I solve t minus 6 equals 0, I get t equal to 6. If I look back at the problem, t is in seconds. So, and we were asked, how long does it take the object to hit the ground? It takes 6 seconds for the object to hit the ground. And that's my final solution. In the application problems, I want to answer with a complete sentence.